Okay, so we are learning 2A, justifying steps. So to justify these steps, I like to show my work, like right over here, I'm going to show my work. And we don't put our work in the proof. In the proof, we just write each step. So we always start our proofs with what was given to us. So what was given to us is this equation. So I'm going to write it. 2x plus 25 minus 6x minus 2 equals 15. And again, the reason I can write it is it was given. And again, we start all our proofs with givens. Okay, so I'm also going to show my work up here. So I'm going to rewrite it up here. 2x plus 25 minus 6x minus 2 equals 15. Now, I have a bunch of like terms on the left-hand side, so I want to combine them. And remember, when I combine them, I do exactly what it says. I don't do the opposite like I do when I'm moving from one side of the equation to the other. So what is 2x minus 6x? And that's negative 4x. And positive 25 minus 2 is positive 23. So now I've combined like terms. So right here I'm going to write down what I got, which was negative 4x plus 23 equals 15. And again, what I did was combine like terms, but the property for combining like terms, the reason is simplify. Okay, now for number 3, to solve this, I need to get negative 4x by itself. So I'm going to subtract 23 from both sides. So I'm going to do that up here where my work is. And I get negative 4x equals, well, 15 minus 23 looks like negative 8. So it looks like I get negative 4x equals negative 8. And then I look, what did I do here? I subtracted 23 from both sides, so that is what we call the subtraction property. And then finally, I'm going to solve. So to do that, I'm going to divide both sides by negative 4, and I get x is positive 2. So right here I get x is positive 2. And again, what I did was division property because I divided both sides. Okay, so that's the answer. Now I can double check it if I want. Maybe I'll do that in blue down here just to make sure that you get the right answer. This isn't part of your proof. This is just for you to check. Just to make sure that you're getting the answer right. If I replace x with 2, I get 2 times 2. I'll do it right here. 2 times 2 plus 25, and then minus 6 times 2 minus 2, and I want to know if that's going to equal 15, and I guess I should have written it up a little bit, but there's 4 plus 25, and negative 6 times 2 is negative 12 minus 2, and I want to know if that equals 15, and again, 4 plus 25 is 29, 29 minus 12 is 17, and 17 minus 2 is 15. So I do get 15 equals 15. So it checks. Okay, number 2 is the segment addition property proof. Okay, so again, our proofs like this are either going to be adding a segment together or adding an angle together. This is a segment. So I know that xt is 3x plus 22, and tz is 5x minus 17, and I know that the whole thing is 77. Okay, and I'm going to look at this and I'm going to say, alright, what I'm given is all this stuff, so let's write that down first. Xt is equal to 3x plus 22. Tz is equal to 5x minus 17. And xe is equal to 77. And again, that was given, so that's why I'm allowed to write that. Okay, now I'm going to look at this and I'm going to say, alright, look at this. I have this part, xt, that's a part, plus this part, tz, and that equals this whole segment, and that whole segment is what we are calling the whole. So I'm going to solve this now by writing the names of the parts that I'm adding together to get the whole. Okay, so the names of the parts, this first part, that 2x plus 22, the name of that part is actually xt. 3x plus 22. But I'm going to say xt plus the second part here, that 5x minus 17 part, and the name of that is tz. And that equals the whole, and the whole is 77, which was xz. Okay, now I'm adding segments together, so this is the segment addition postulate. Okay, for number 3, I'm going to now replace xt with the number. So the number that goes with xt is 3x plus 22. And tz, which is the number that goes with that, is 5x minus 17. And then I know that xz is 77. So that gives me the equation. And again, I was replacing xt with how long xt is. Okay, and replacing is a substitution property. So that's why I'm allowed to say that. Okay, now, remember, I like to say you do given, name, number. So I was given this stuff, so given. Then I write the names that I was adding together. So I was adding together xt plus tz equaling xz. And then I replace those names with the numbers, which are 3x plus 22, 5x minus 17, and 77 in that substitution. So given, name, number. Then you solve. So I have to solve this. Again, I have some like terms here. I have 3x and 5x. When I add those together, I get 8x. And 22 minus 17. Remember, these are all on the left-hand side, so I just combine like terms. I don't do the opposite. So I do actually 3x plus 5x is 8x. And then 22 minus 17. And that's, I believe, 5. And that equals 77. And remember, combining like terms is simplify. Okay, now it's time for me to show some work. So I'm going to pick a new color out and do this yellow so I can solve it up here. And it looks like I have 8x plus 5 equals 77. Okay, so how would I solve that? Yeah, I'd subtract 5 from both sides. And I get 8x equals, well, 77 minus 5 is 72. So I get 8x equals 72. So that's, whoops. Sorry about that. That's what I'm going to write here in purple. I'm going to say, alright, number 5, I get 8x equals 72. But remember, what I did was subtracted the 5, right? So when I subtract something from both sides, that's the subtraction property. Okay, and then I have to solve this. So again, let me get the yellow. And I need to get x by itself. So to do that, I'm going to divide by 8. And I get x is 72 divided by 8, which is 9. So I get x is 9. So I'm going to say, alright, x is 9. And again, what I did was division. So that's a division property. Okay, so x is 9. Let's just make sure that works. If I plug it in right up here, I get 3 times 9 plus 22. Well, that's 27 plus 22. And that's 49. And tz would be 5 times 9 minus 17. So 45 minus 17. Well, 45 minus 10 is 35, and 35 minus 7 is 28. So let's see, what is 49 plus 28? 49 plus 28 is 77. 9 plus 8 is 17, carry the 1. 6 plus 1. Sorry, 4 plus 2 is 6, plus the 1 that I carried is 77. So it checks out. Okay, and that's it. So these you tries. Okay, so remember you have to complete these on your own, or at the math lab, or in your tutorial support class, or your geometry support class, and then you have to have it signed by a teacher. Okay, so here's this problem. Again, write it down, solve it. Okay, now this one's just like the second one we did, but be careful here. We're adding angles instead of segments. We're adding angles instead of segments. Okay, and when we name angles, we use the three-angle name, the three-letter name, EBF, right? Okay, so be careful with that. All right, good job.